In this video, I will discuss a concept related to secure network design, and it is known as domain separation. So there are two types of domains in network security, that is a collision domain and broadcast domain. So I will compare both of these domains with regards to these features, that is their definitions, scope, separation of collision and broadcast domain, risk and mitigation, and key takeaways. So collision domain is a shared network segment or a shared media where data packets collide when these are sent simultaneously by two devices. Then both of these devices need to resend these packets. Whereas broadcast domain is a logical division of network where devices receive the same broadcast traffic if they are in the same broadcast domain. And these devices interact with each other at data link layer in the same broadcast domain. So collision domain is smaller in size. For example, all ports on a hub are in same collision domain. Whereas once we talk about the switches or higher devices, then each port on switch or higher device is in a separate collision domain. Therefore, collision domain is small. Whereas broadcast domain is larger. Uh, for example, we can have multiple devices within a single broadcast domain or within a single network segment. And then these broadcast domains or these network segments can communicate with each other via layer 3, that is the IP layer of OSI model. So they can communicate via layer 3 gateways, for example routed VLAN interfaces. Now separation of collision domain reduces the collisions and therefore improves the network efficiency. However, it has no direct impact on security. But once we talk about security, so there are three cornerstones of security, that is confidentiality, integrity, and availability. So separation of collision domains improves the availability of network services. Whereas broadcast separation of broadcast domain directly impacts the security. So this separation reduces the broadcast and therefore limits unnecessary exposure of network traffic. Now, how high collision can lead to network congestion and performance issues. And large broadcast domain provide more attack surface to hacker who is performing the network reconnaissance. Moreover, in large broadcast domain, it is difficult to isolate network issues. And moreover, it also consume more bandwidth because all the devices in a single broadcast domain receive all the broadcast traffic. Now, in order to mitigate the collisions, we can use L3 for the L2 devices or higher devices. For example, bridge, switch, and router. So bridge and switch are L2 device, whereas router is a L3 device. And L2 is a data link layer, and L3 is the IP layer of OSI model. So once we use the bridge, switch, or router, then it separate the collision domain. and therefore there is less collision. Whereas in hub there is more collision, and hub is a layer 1 device, that is the physical layer of OSI model, because all the ports in a hub are in the same collision domain. So once the devices which are connected to the ports of hub send the traffic, then there are chances of collision because their collision domain is same. So in order to separate the broadcast domain to make it smaller, we can use L3 or higher device. For example, L3 switches or routers. And each port on an L3 device has one broadcast domain per port. So each port is in a separate broadcast domain. And if we are using switches, then we can use separate VLANs to separate the broadcast domain. So there is one broadcast domain per VLAN, and VLAN operates at data link layer, that is layer 2 of OSI model. Or we can use different subnet to separate the broadcast domain. So there is one broadcast domain per subnet, and subnet operates at layer 3, that is IP layer of OSI model. Now key takeaways are that in collision domain, the main focus is on improving the network performance by reducing the collisions or by separating the collision domains. And in broadcast domain, the main focus is in isolating the local network segment or local traffic, or by separating the broadcast domain to make it smaller, which limits the hacker ability to sniff or to perform reconnaissance to know about the network topology. So thus it reduces the network attack surface, because then you have a smaller broadcast domain, so there would be a smaller attack surface. So this was all. Thank you.